Hi everyone, and welcome to this lesson. This lesson we're going to be looking at how exactly we set up or break out structures inside visualizations or SCADA packages, HMIs, etc. Now, obviously we're using Codesys here, and each package will vary. So Siemens, for example, is very different, but the principles are still the same. You can still pass structures to objects in your HMI system or SCADA system. It's relatively new in WinCC for Siemens, but you can do it now, and it works very, very well. So with that said, let's go offline and have a look at exactly what's happening in the background. So I'll just make this on a single screen. Oops. So what we have here is a object, and this object isn't just the standard gauge that gets dropped from the visualization toolbox, which is on our measurement controls, which is this. So although they look the same, this one is actually something that I've made called analog gauge. So if I drop another analog gauge on, which you can do once you've made a visualization, it becomes available in the current project toolbox. If I drag one of these on, it pops up saying, these are the parameters that are required for this visualization, and it's in here that I would say I want to pass my pressure to typed analog, which is my DUT analog. And notice that it's only allowing me to pass structures that are compatible, which makes this nice and easy again. You can only pass what will be accepted. So now I have two, one's looking at pressure 1 and one's looking at pressure 2. Let's have a look at how this is made up. So if I have a look at analog gauge here, now this here is the standard Codesys gauge. So I just drop one of these in. I have my declaration window at the top, which comes default as closed. So you need to click the little down arrow to open it. I think once you've opened it once, it will stay open for other visualizations that you open. But here I've got a INOUT again. Still passing, well, everything's passed by reference really in the visualizations. You can pass inputs and outputs, but I don't think it actually makes that much difference to a visualization. I might be wrong there, but it comes default saying var in out, and it expects things to be declared in var in out. So you put in here your analog data, which is the name, and then my reference, my data type, which is DUT analog. So if I click on this and have a look at the properties, there's quite a lot of properties in here, but I'm interested in a few things, which is the actual value that I want to display, and I also want my scaling to be set up for me, because we already have access to that information through our structure. So value here is just analog data.scaled, and then I want to have a look at my actual scale. So scale start, you can see that it says 0 to 100, but those are the constants. So I need to actually expand it to have a look at the variable that I've got set. And I'm looking at analog data.scaling data, because we know that's going to be available to an analog, and then scale min. Same with scale end, scale max. And then my main scale, because in Codesys you can do calculations in sort of variable declaration spaces, variable mapping spaces. I'm doing my scale max minus scale min divided by 4, so I get a nice scale range across my dial, and I do the same with subscale, but divide by 8. You won't be able to do that in every single visualization system. You might have to do that in the PLC, for example, and have it as part of your structure, or expose it on the outside of your faceplates, or up in here. put in what you want that to be and assign it that way, which means you could at least expose a property that would update when you drop this wherever it is that you want to use it. And if I'm honest, that's pretty much it. All you're doing is exposing a DUT analog to the outside of this visualization, or as Siemens call them, faceplates, and then populating that with information from your PLC and breaking it down inside this visualization, which means from the outside you're only passing in one data set. And just like the PLC, if that data set grows, that structure grows, this grows as well, and you can make use of this new stuff that's been added in. So let's log in and have a look. Just log in with a online change. So what we can see now is that pressure 1 is configured with information from our previous lesson, but pressure 2, because we're looking at a different one, hasn't been configured with anything yet. So let's go and have a look at configuring that. Because it's in its own global block, it's its own sort of data set. Changing one won't affect the other, which is exactly what we want it to do. So let's give it some scaling data. So I'm going to do the same, 4,000 and 20,000, and give it a min of 0, but this one is going to be to 10. So let's download that. So I get my automatically scaled dial, and then if I give it a raw value of 12,000, so 50%, I'd expect that to go in the middle, which it does. And that's it now. Just remember that I've gone down a layer in our structure as well. So although our pressure transducers are set up as DUT pressures, they contain a DUT analog here. So if I was to go and create a level transmitter structure, that would need to contain a DUT analog as well, because it's still an analog device, and these dials would then be compatible with that instrument as well. So in the case of pressure, we don't have anything else really. There's nothing else happening in the pressure structure other than the analog. But in a level, we might have other things like volume of the tank and sort of fill levels and all that sort of stuff going on. But we would still always have a DUT analog, because that is the sort of core basis of the instrument, and therefore these dials would be compatible. So hopefully that makes sense. This is one that you should try, mess about with, and build your own sort of visualization and pass it your own structure and have a look at what you can do with this. Don't forget that you can do this stuff for setup pages as well. So a really good idea would be to provide a sort of widget or another visualization that allows you to set this information that I'm setting here directly in the global variable list, because obviously you'd need somewhere to actually set that information in a HMI. People aren't going to be coming into the code to set this stuff, so that's a good little task there to try and understand what's happening here.